Hi, so you found us because you're interested in making a bike generator. Well, I hope we can help you out here by showing what we've done with an exercise bike, an alternator, and a few extra parts to light up some light bulbs. So I'm Tom Gloria, I'm an environmentalist, and I'm working with my son Patrick and my daughter Isabel to help me out today on making the bike generator. So what we did was we took your typical exercise bike that was collecting dust. You can find it from your in-laws and other places, and just rejuvenate this little puppy into something that's now useful for science and education. So simply what we did was we took an automobile alternator. Others that you may have seen on YouTube have done this, so kudos to them to showing us how this was done. We put on a little friction gear mechanism. It's just an average automotive bushing bolted on here, and they simply bolted the alternator right to the bike with a flat piece of holed steel. And then the other key piece is this little piece down here of hardware. It's called a turnbuckle, and that'll allow you to dial in the friction that you need to have to make sure that the friction gear works properly. Now, another thing about alternators, they do make nice generators. They clip the voltage to 12 volts, but they also need a little energizer circuit that allows them to sense when everything is happy for them to create the electricity. So a couple of things about that is, number one, you need to energize the circuit associated with the alternator. So I have a switch mechanism up here, easily accessible. The bike, when it comes up to speed, you've got to energize the circuit. In order to power that, put together a simple bank of rechargeable AA batteries. 10 of them creates a nominal voltage of 12 volts, or about 1.2 volts apiece. So when they're fully charged, you'll get a reading of about 13 volts or so, which is important. You want your batteries to be charged, ready to go, so your alternator senses that it's happy in a car and ready to operate. Now, the other piece that we have to do is Patrick is going to bring the bike up to speed first so that the load will be satisfied. Now, we need to get it within a 1,000 RPM speed in order for the alternator to operate and deliver current. So, estimating that, Patrick needs to get to at least 20 RPM. We found that if he gets up to 50 to 60, somewhere around 90 RPM, which is easily obtainable, Patrick can create a nice steady current, about 14.5 volts. All right, Patrick, let's bring it up to speed. So Patrick's going to cycle up to speed. At 13, we're going to flip the energizer up to 14. Now Isabel is going to take our standard inverter, takes the 12 volts, brings it up to 120 AC, bank of incandescent, 1, 2, and that's about all that Patrick can do. So we're going to reset the circuit, turn off the bulbs, turn off the inverter. Okay, very good. Alright, and then we're going to do it again with compact fluorescents. The compact fluorescents are similar in size to the 60-watt bulbs that are incandescents, put out the same amount of light, about 800 lumens, and they only operate on 14 watts a bulb to produce the same amount of light. So let's see Patrick produce the same amount of light, but more efficient bulbs. Go ahead, Patrick. Comes up to speed. Energize the circuit. 14.5. 1 bulb, 2 bulbs, 3 bulbs, 4 bulbs, and there you go. Energy efficiency in action. So there you have it. So a simple bike generator made from an exercise bike, an alternator with a field circuit. That field circuit needs to be about 12 volts. Also, we have a standard inverter that takes the 12 volts, brings it up to 120 volts AC, and then a bank of lights. And there you go. Good luck.